In this video, we're going to take this concept of a confidence interval where we know that we have a sample average, but we also know that that sample average, it's possible that the real value could be somewhere higher or that it could be lower. So again, we're going to take this idea of a confidence interval and we're going to go in and we're going to create what we call a hypothesis test. In this particular example, we're using example 6.10 out of the Jaeggi et al. Business Analytics textbook. And the data that is presented is that there's a dean at a large university in California who has read that students are not studying as much as they used to, that in 1961 the national average was 24. Okay, it used to be 24 hours per week. However, she's gone in and had somebody do a sample of 35 students, and the average that she's seeing with her university is that it's currently around 16.4. So using a hypothesis test, it says, based on our sample here of about 16.4, is 24 still valid, right? Is it still within a 95% confidence interval? So there are 4 steps that we normally go through to conduct hypothesis tests. The first one is we need to state the null and the alternative hypothesis. And the null hypothesis says, usually, what is the status quo or what has been the status quo in the past. And in this case, that is, our null hypothesis is that the current mean is greater than or equal to 24, all right? So the way we're going to write that in there, if you click on Insert and you go to Symbols, you get a lot of symbols that you can add here. You can scroll through this to find the Greek letter mu. I've used it in the past, so I'm just going to go click on it, Insert, and Close. And what I just stated was that we have that this is greater than or equal to 24. That means that our alternative hypothesis is that mu is less than 24 hours a week. The alpha level that we're referring to here, we want a 95% confidence interval. So remember, the alpha level is whatever the confidence interval is, 1 minus the confidence interval. So 1 minus 0.95. So our confidence interval is 0.05. So this is a 5% tail that is over here. Our average in this case has been given to us. The dean had someone calculate this based on her study, and it's 16.3714. And from that, the mu, the original mu that we're talking about here, that we were referring to in the past, is 24. Our standard deviation is also given to us as 7.2155, and the number of students who were sampled is 35. Okay, so from this now, we can go in and we can calculate our t-statistic. Now, the reason that we're doing a t-statistic of 34 is because we have 35 people that we sampled. Degrees of freedom is the sample size minus 1. All right, and the way we're going to calculate that is it is the average that we have calculated minus the mu, which is the original average. And now we need to separate those by parentheses so that those stay out of the calculation. And we're going to divide that by our standard deviation. And we're going to divide that by square root of n. Make sure that we have everything closed off. It says we have a typo, let it correct it, and we come up with a value of minus 6.2479. The last thing that we need to do now is we need to calculate, let me just move this down 2. We need to calculate a p-statistic, and that p-statistic is the probability that we are, based on this t-statistic, what is our p-value? All right, and the way we enter that is equals 1 minus t-distribution for a right tail test, and the value that we have is minus 6.25479. The last argument that needs to go in there is the degrees of freedom, which is n minus 1, that's 34. And so we end up calculating here 2.01 times 10 to the minus 7. This value is significantly lower than 0.05, right? And that's the p-value we're looking for. Since it's significantly lower than 0.05, that means we have less than a 5% chance that the results that we just came up with is based on random sample variability. Because the p-value is less than 0.05, that means that we reject the null hypothesis. Rejecting the null hypothesis says that statistically we can say that the difference between what is now and what was in the past is statistically significantly different. All right, hopefully that helps you get through this and shows you how to do a hypothesis test with known standard deviation and known average.